It is often important in mathematics and in applications to determine the maximum and minimum values of a function. So in this video, we will look at a graph and determine its maximum and minimum values. First, there are two different types of maxima and minima. We have local and then we have absolute. So local means that we are looking at a particular neighborhood or a particular interval. So, for example, a local maximum resides here. Now you'll notice that this curve, if you follow it, continues up higher and higher and higher. So this is not the highest point on the graph. In fact, we have a point right here that is higher. But locally speaking, on this interval, if we look at just the neighborhood surrounding it, the locality surrounding it, this is the highest point. So we would call f of c the local maximum. Likewise, over here, this point is not the lowest point on the graph. There are obviously points even falling below the x-axis. But on this region, it is the lowest. So this is a local minimum. Now you'll notice that we say maxima and minima. Those are the plural forms of maximum and minimum. So one maximum, two minima. One minimum, two minima. And then if I don't want to talk about maxima and minima, and I just want to talk generically about all maxima and minima, I can talk about extrema or extreme values. And so likewise, you have extremum and extrema. So let's take a look at an example. If we have this graph and we want to find the local or any local maxima, where are they? So let's go ahead and take a look. Do we have any local maxima? So as we go through our curve, do we have any points where we're higher than the others around it? So here we have a high point, and likewise we have a high point right here. So we do have two local maxima. So we have, first off, we're supposed to find the numbers, if any, at which f has a local maximum. So the numbers at which, so we would say at, now what's the x value? -2 and +2. So at x equals -2, we have a maximum of, and now what is the maximum value? 6. And then likewise, at x equals 2, we have a local max of 2. I should probably be more careful and say these are local. Now we do the same thing, but this time we're looking for local minima. So do we have any points at which we bottom out, so to speak? Go ahead and try this one. Pause the video and determine any values at which we have a local minimum and determine what they are. So you would again say at x equals, so on and so forth. So pause the video and write them down. So as we move across the function, you can tell that we bottom out here and then also here. So I'll mark them so that we can refer easily back to them. So at x equals 0, we have a local minimum of -2. And then likewise, at x equals 3, we have a local minimum of -4. And now we have the concept of absolute maximum and absolute minimum. So an absolute maximum is, if you look at the whole graph over its entire domain, what is the highest value? And likewise, if you're looking at the absolute minimum, it's over the entire domain, what is the lowest value? So let's take a look at an example and find the absolute maximum and minima if they exist. So is there a point on this graph that is higher than all the others? So you'll notice as we move, the highest point is here. There is no other point on this curve that is higher than all the others. So we have an absolute maximum of, and then what is the value? What is the actual maximum? The maximum is 6, and it's at what x value? It's at 3. Then, now do we have an absolute minimum? Do we have a point that's lower than all the others? So it looks like we're bottoming out right here, and there is no point lower than this. The problem is that there is no point on the graph right here. It's a hole. So as we get closer and closer, there's not a point that is obtainable on our graph. So there is no absolute minimum. Now, are there any local maxima and minima? So local maxima and minima must occur within the interior of our function. It cannot occur on the boundary values. So while this point might be higher than those surrounding it, it has to be there must be an interval around it on the left and the right. Likewise over here, we have to be able to look to the left and to the right and see that it's higher. So we can't look at the endpoints. Do we have any local maxima? Now, we do have a local maximum, and it's the same thing as our absolute maximum. We have a local max of 6 at x equals 3. Do we have any local minima? Any points that are lower than the surrounding points? And the answer is yes. If we look at this point, it is lower than the surrounding points. So we have a local minimum of 2 at x equals 2. Now take a look at this graph and see if you can find an absolute maximum and an absolute minimum. Now we do the same thing on this graph. Let's look first for any absolute extrema and then any local extrema. So, absolutely speaking, do we have an absolute maximum? Do we have any points that are higher than all the other points? This point is higher than every single point on the blue curve. So we have we have an absolute max of 5 at x equals 3. And then likewise, we have an absolute minimum of -1 at x equals 5. Now, do we have any local maxima and minima? And you'll notice that this point on the interval surrounding it is higher than the local surroundings. Likewise, this is locally a minimum as well. So we have a local maximum of 5 at x equals 3. And we have a local minimum of negative 1 at x equals 5.